In this video, we will discuss aviation safety. Safety is boring. It's messy. It's hard work. And it's expensive. But in the aviation industry, safety is everything. We are keenly aware that the rules and regulations of today's aviation procedures have been born of a century spent experimenting in manned flight at the cost of broken aeroplanes and shattered lives. Safety is risk management. The risk management consists of layers which separate the pilot and his aircraft from the persistent threat of an accident or incident. These layers are named as ground school, simulators, pre-flight planning, aircraft, flight monitoring, and experience safety reporting. In the aerospace industry, these layers are manufactured by a strong safety culture through an organization-wide safety management system. Let's discuss these layers in detail. First is ground school. At ground school, pilots study aviation safety, where they explore topics like crew resource management, human factors, air regulations, aviation meteorology, air navigation, radio communication, and physiology. Next is flight simulator. Flight simulation is used for a variety of reasons, including flight training. It includes replicating the equations that govern how aircraft fly, how they react to applications of flight controls, the effects of other aircraft systems, and how the aircraft reacts to external factors, such as air density, turbulence, cloud, wind shear, precipitation, etc. We now come to pre-flight planning. At the airport, pilots are trained with thorough pre-flight planning, where they learn to mitigate the risk in adverse flight conditions. Pre-flighting of an airplane is the process of inspecting it prior to takeoff. The standard checks of an aircraft are done as follows. First is using a pre-flight checklist, which is filled by the pilot for mandatory checks such as door exit, fuel, etc., before taking off. Next, the pre-flight check of the cockpit is always done on priority. This ensures that the cockpit equipment is properly working and the fuel tanks have sufficient fuel for flight. Next is exiting the aircraft. As you climb out of the cabin, take a look at the seat support rails. Check the cabin door to be sure that it operates smoothly and shuts securely. Next is inspection of the aircraft from outside to identify any damage caused by impacts or cracks and seams separating from airframe fatigue, hard landings, or other mishaps. The next step is inspecting the right wing after exiting the aircraft and looking at the forward wing surface for nicks, loose fasteners, dents, or other damage. Next is removing the fuel cap for wing fuel tanks and visually confirming whether the aircraft has sufficient fuel for the flight. After this, check the stall indicator, which indicates whether the control column is functioning properly. Next is inspection of the tail assembly. While at the tail, you may remove the wheel chock or tail tie-down. Look at the elevators and the rudder. As with all control surfaces, these should be tight with no loose motion or free play. Now move to the front of the aircraft and look at the exhaust, looking for oil blowout and other damage. Now, moving on to the propeller pilot's checks, the pilot has to check the rotation by rotating the propeller manually. Check the spinner for lubricant leaks, missing bolts and pins, or other problems. Look at the propeller itself to be sure the blades are not cracked, bent, delaminated, or damaged in other ways. Next, take a look at the wheels, landing gear, and landing gear compartment doors. Look for loose fittings, tires which may have tread separation, low inflation pressure, and other defects. I hope this video helped you to understand the basics of aviation safety.